All right. Let's start making our way through this here. How would you describe this distribution?
I said the data shows it's roughly symmetric.
It is roughly symmetric.
And then I said 78 is an outlier. The median is 67.5, and the IQR is 4.5.
Yes. Thank you. Yeah. You want to make sure that you are weaving context in here. That's okay. I'm just little reminders there. So you would want to say like the distribution of heights of AP students or heights of these 20 AP students. And whenever you're giving measurements, you'd want to make sure to include units because that's another way to make sure that you've hit that context marker. So you talked about the high outlier. Did anybody identify anything else that they're like, I think that might be an outlier too?
Yeah, there's an outlier at 56 inches.
Yes. 56 inches is an outlier. And that one at what, 78? Yeah, okay, there we go. 78 is an outlier. Since we described this as roughly symmetric or approximately symmetric, what would be the best measures for center and spread? Mean and standard deviation. So that's what I would use in the description. If you described it as approximately symmetric and you have access to that information, which we did on this one, that's what I would use in my description of the distribution. You do still have to find the IQR if you're going to identify whether or not there's any outliers. So we had Q1 and Q3 given to us. The only other thing that I noticed about this one is that if I kind of draw over the top of it, it almost looks like what? It almost looks bimodal. So you could say it appears to be perhaps bimodal and approximately symmetric. That would be the only other thing that I might add other than, again, making sure you're weaving context in. So tell me what it's a distribution of and make sure you're using those units and occasionally maybe pull in the heights are whatever, right? Because you want to make sure that you're not getting knocked down for that particular piece. Ariana is 65 inches tall. What percent of heights are less than or equal to 65? 25%, 5 out of 20. So we would say that Ariana is at the 25th percentile. For your height, obviously everybody's answers are going to be a little bit different. Let me pick on somebody. Israel, what's your height? 69 inches. All right, so if I was going to do this with 69 inches, how would we calculate the percentile for 69 inches? Absolutely. So when I come up and I look here, there's 2 right at 69. I have to count them both and everything below it. So 1, 2, 3, 4, 5, 6, 7. Oh, hold on, I lost my count. 5, 6, 7, 8, 9, 10, 11, 12. Looks like 13 out of 20. What would that percent be? 13 out of 20. You said 65%? Absolutely. Guys. Here you go. I'm so sorry. All right. I'm sorry, you guys said 65%? I didn't write it down. 65? Okay. All right, let's talk about the bottom part of this page, 3 and 4. Frequency, these are the counts. If it says frequency, we're looking at counts. So how many people had those responses? How many people were there between 56 and 60? 1. Between 61 and 65? 4. Between 66 and 70? 11. 71 to 75? 3. And 76 to 80? 1. Relative frequencies. These are my percents. So I'm calculating what percent of the population was between 56 and 60. So now I'm doing 1 over 20, which is 5%. For this next group, it's 4 out of 20, which is how much? 20%. 11 out of 20, 55%. 3 out of 20, 15%. And 1 out of 20, which is 5%. Cumulative relative frequencies. This is where my percentile comes from. So when I asked, what percent of people were at Ariana's height or shorter, and then we did that with Israel's height as well. This is where my percentiles are going to come from. When I do the cumulative relative frequency, I am adding as I move down. So this first one is 5%. But to get this next one, now I'm adding these two numbers right here. 25%. And then I take that 25% and I'm going to add it with this one to get this. What is 55 plus 25? 80%, 95%, and 100%. This will always end with 100%. Always going to end with 100%. I can take that cumulative relative frequency and I can plot it. I'm actually going to change. These shouldn't be whole numbers here. This shouldn't be 20. This should be 20% or 0.2. I'm going to write that as 0.20, 0.40, 0.60, 0.80, and up here at the top is 1. These are all percentages. I'm just writing them in decimal form. So this guy's 100%, 80%, 20%, and so on. You guys okay with that? All right, I want to plot this. From 55 to 60, our cumulative relative frequency was what? 5%. So 5, let's see, here's 10. So about here. How many people were 55 inches tall? None. So what percent would that be? 0. So I'm going to have my first point over here at 55 at 0. 61 to 65. What percent? 25%. Here's 30, so here's 25. Notice I am putting this like at this spot on each of these. That's where my dot is going, is on the upper end of this. My dot is going on the upper end. And then we go up to what? Then we go up to 80%. Notice that my graph kind of jumps up a lot here because there's a lot of data, so it has like a very high slope. And then we go to 95. It's going to be about here. And then up at 100. And I'm going to trace through these. That is called a cumulative relative frequency graph. Cumulative relative frequency graph. And I can use this cumulative relative frequency graph to find out the percentile for different pieces of individual data. I can use this graph to estimate that percentile. So I want to go ahead and practice doing that right now. It says Mrs. Gallagher is 66 inches tall, and I want to estimate and interpret the percentile she is at using this graph. So 66 would be about here, right?
Yeah.
I'm going to follow that up until I hit the graph.
About 40.
Yeah, and then I follow it over like this. 40, 45%, something like that, right? So, or sorry, 35 to 40%. Mine came in just shy of 40, so I'm going to call it 35%. If you're estimating, we can, excuse me, we can only get estimates from these graphs. So as long as your estimate, if I see how you're getting it, and your estimate seems reasonable with what I'm seeing, you're fine. So 35%, how would I interpret that in context then?
35% of the class is shorter than her.
Yeah, they are at or below her height. 35% of the students are at or below Mrs. Gallagher's height of 66 inches. Or Gallus, I think I've been pronouncing her name wrong. How can I do something similar to that, but to estimate and interpret the 80th percentile? How would I do that? How can I use the graph to help me do that? Exactly. We're going to do this backwards from what we just did. 80% is right here, so I'm going to kind of track this over. We actually had a data point right there. If I take that down, looks like it's about 70 inches. So 70 inches. How would I interpret that then? What does that mean in the context?
80% of students are at or below 7 inches.
That's exactly right. 80% of students are at or below 70 inches. Beautiful. Beautiful, beautiful. One of the things that I want to point out, excuse me, we are at a percentile, not in a percentile. Percentile is describing like a location in the distribution. You could describe yourself as being at the corner of 71st and Georgetown, but you would never say you're in the corner of 71st and Georgetown. So this is an at thing, because again, we're describing a location in this distribution. Flipping the page over, a couple big ideas. We had two different learning topics for today. So to hit on this first one, percentile. And that is way smaller than I want it to be. Here we go, percentile. The percent of values less than or equal to a given value. And again, you are at a percentile, not in it. All right, so that's kind of the first big thing that we touched on. Cumulative relative frequency graphs is the other thing that we really touched on here. Oh, forgot a letter. There we go. Cumulative relative frequency graph. So cumulative relative frequency graph, over here, we're going to have the proportion always ending with 1. And depending on how I set up that axis, we can count by whatever we deem appropriate. So like 0.25, 0.5, 0.75, all the way up to 1, which would be the same as 100%. And then my cumulative relative frequency graph is always going to start down here on the x-axis. We always put the first dot there because there is somewhere that is the 0th percentile. And then we'll get our other points here. And it's never going to go above what percent? 100%. It has to get to 100%. So down at the bottom, I have my data values. If I use my cumulative relative frequency graph to estimate the 25th percentile, that is the same as Q1. 25% of my population is at or below this value. The 50th percentile would be the same as what? Median. What other value might I be really interested from here? 75, because that is what? Q3. And I'm doing percent and an ile, so I have percentile. That's what that ILE on the end is. I'm just not writing out percentile. I'm doing the first part. I just wanted to make sure that that's not some weird cryptic symbol. I'm just abbreviating percentile there. All right. We've got about 5 minutes left. I want you guys to see how you can do on that check your understanding down at the bottom. I want you to go through and try to answer those questions down at the bottom of the page with our last 5 minutes.